Hi everyone. Today my topic is about transformers. Before going to explain about transformer, I would like to give glimpse about transformer. It means how does a transformer operate and what is the principle of which law is used in transformer. And before going to say that, have you ever noticed that electricity is transmitted at higher voltages, but our home appliances applications like mobile charger and laptop, everything requires only 5 volt AC, and other equipments require around 230 volts AC, 440. So firstly, a generating station, power is generated. It means voltage is generated at 12 kV in generating station. But if we transmit the 12 kV in transmission line, and if we consider any drop in the transmission line, at the end we will get less voltage. So in order to avoid that, at generating station we generate voltages at 12 kV, and we basically step it up to 400 to 765 kV voltage, and then we basically transmit at higher voltages. Why? Because at higher voltages drop in the line will get decreased. I will explain how it is decreased. I will explain after a while time. So now if we transmit at high voltages, losses will become less. It means even size of the conductor is less. I will explain why. So we basically transmit electricity at high voltage. At the end time, at the utility end, at the consumer end, we basically step down high voltage to low voltage. That is, the voltage we require is 440 volts, 3-phase AC, and single phase 230 AC. It means high voltage is again stepped down to some low level voltage. This both are done. It means stepping up to high voltage at generating end and stepping down to low voltage at the utility end. Both are done by one electric static device, which is nothing but transformer. This is the use of transformer. See, what I am going to say is a transformer is nothing but it's a static electrical device which transfers or else which changes voltages from one level to other level. It means if the voltage increases, it is step up transformer. If the voltage decreases, it is step down transformer. So what is step up and step down transformer? I will explain in a while. I have said that electricity is generated at an high voltages, and what is the reason. And before going to explain about transformer, it is not only a transformer but all the machines in electrical engineering, I would like to discuss about Faraday's laws of electromagnetic induction. So here, so I have said that we basically generate voltages at low voltage, that is 12 kV, and we basically transmit electricity at high voltages. And what is the need to transmit voltages high level? Here I will explain. Here basic apparent power which is transmitted is given by root 3 VLIL. From here I can say that I can write IL as S by root 3 VL. It means power loss in a transmission line is given by, basically in 3-phase we basically given by P loss is equal to 3 into IL square into R. If I submit this IL value in this equation, 3 is equal to S by root 3 VL whole square into R. It means what I can say is power loss in a transmission line is inversely proportional to, it means VL square. It means what I am going to say is if I transmit voltages at higher level, my P loss, it means if I transmit voltage at higher level, my P loss in a transmission line is getting decreased. It means if I increase the voltage by x times, my power loss is decreasing by 1 by x square times. This is the reason why we transmit power at high voltages. So this is the reason, and which we can achieve by using electrical equipment called transformer. At the same time, at the utility end also, we need less voltages. It means the high voltage is getting stepped down to low voltage. That is also acquired, that is also achieved by equipment called transformer. And this is usefulness of the transformer, and this is transformer. And the next question comes into our mind is, how does it operate? So this is a very important thing to learn. It means how does it operate. So what is the principle of operation of transformer? Basically, transformer operates on the principle of Faraday's laws of electromagnetic induction, which states that induced EMF is nothing but minus n d phi by dt. It means before going to explain about the operation of all the machines, we would like to know about the importance of induced EMF. Basically, this is what d phi by dt. It means what I'm going to say is E is equal to minus d phi by dt. What does it indicate? What does this negative sign indicate? What does this negative sign indicate? The negative sign indicate the Lenz law. It means what I'm going to say is induced EMF in a conductor. This is how is the EMF induced? Is when there is a relative change, when there is a relative space or time variation with respect to magnetic field and a set of conductors. When there is a relative space or time variation between magnetic field and set of conductors, EMF is induced. An EMF is introduced, and if the circuit is closed, current do flows from it. So what I'm going to say is, see, in order to induce EMF, either my flux need to be vary, my conductors are to be at static, or else my flux is static, my conductor should be in movement. See, anything, there must be a relative motion between the two. See, in some time flux may be variable, conductor is static, EMF is induced. In some cases conductors are moving but flux is static, there also EMF is induced. Basically, induced EMFs are of two types. One is statically induced EMF. Another is dynamically induced EMF. Statically induced EMF is nothing but, here we basically give alternating voltage by which alternating current is produced. Alternating voltage we give, alternating current is produced, and alternating current, when it is flows through all the turns of the coil, then a flux is produced. That flux will link, the flux is cutted by the static conductor or static coil, therefore an EMF is induced in it. So in this way, when the flux is variable, the conductors are static, the resultant induced EMF is nothing but statically induced EMF. On the other hand, dynamically induced EMF, what does this dynamically induced EMF means? Here what happens is, our flux is constant, our flux remains constant, like a constant flux flows from north to south. Then the set of conductors present in the magnetic field do rotate. So it means, for example, in the case of DC generator, we basically move the prime mover by which the set of conductors do move, and the static flux which flows from north to south, and a flux is cut by the set of conductors, there the EMF is induced. In that case, we basically call it as dynamically induced EMF. So here we differentiated between two EMF. One is statically induced EMF, another dynamically induced. Statically induced EMF example is nothing but transformers. Dynamically induced EMF example is nothing but DC generators and all these DC motors. These all are the examples of dynamically induced EMF. It means here I have explained the importance of transformer, and also I have explained how the EMF is induced. And the one more thing I would like to explain is the beauty of, or the importance of negative sign present in the this present in this negative sign. For example, I have said that induced EMF is nothing but minus n d phi by dt. It means, what does it negative sign indicates? This negative sign is nothing but it's negative law, which it is nothing but Lenz's law. What does it indicate? If we come to know about the negative sign present in this, we can master every machine present in electrical engineering. So, for example, in case of transformer, we give alternating voltage, and by which we will get alternating current, by which we get alternating flux, by flux cutting, when flux cut with a static conductor, an EMF is induced. So in this way an EMF is induced. It means, what does this Lenz law states? What does this Lenz law state means? Effect opposes the cause. It means finally the induced EMF which is produced by this voltage V, by this voltage V, this E opposes V. It means effect opposes cause. So in this way, direction of current or direction of induced EMF is found by the Lenz law by Lenz law. It means it indicates direction. This effect opposes the cause. Effect is nothing but induced EMF. What is the cause? What is the cause? Supply voltage is the cause. So therefore, induced EMF opposes the voltage. So with this law only we can learn about all the machines present in the electrical engineering. So there actually, finally, I would like to describe what is transformer. A transformer is nothing but it's a static device which transfers voltage level from one level to another level without changing frequency, and also without changing frequency, and it is also a constant flux device. I will explain why it is constant flux device in a while time. So before going to explain about that, I would like to define that, and afterwards I will explain how this transformer is nothing but it's a constant flux device. And before going to say that, I would like to say that always transformer acts on AC voltage. It means it is applicable on AC dose only. It doesn't work out for DC supply. Why? Because induced EMF is nothing but minus n d phi by dt. If for example, if I give in a DC voltage, for example, if I give in a DC voltage, what happens is, see, DC voltage is constant. It means the flux produced by DC voltage is also a constant. It means, for example, VDC is there. The flux produced by VDC and the current produced by VDC is nothing but IDC. IDC produces a constant flux, phi DC. If phi DC is nothing but, see here, if we substitute phi DC in case of n d phi by dt, since phi DC is constant, d by dt of constant is nothing but 0. It means there is no induced EMF produced in the primary side. If there is no induced EMF, if we go on give continuous DC voltage, what happens is, first it goes into saturation, it goes to deep saturation, so which is not and first it will go saturated, and if we go on give the supply as VDC, finally what happens, it gets burnt, So by this what we learned is transformers works on only AC only. In next lecture we will learn about equivalent circuit of transformer, see actually why it is called constant flux device, and EMF equation of transformer, and then we will learn about the losses present in the transformer. Thank you.